All right, the next order of business on the bike is to kind of go through the electrical and figure out what works, what doesn't. And again, we have to assume that most everything worked on this bike, but that doesn't mean that we don't want to take the steps necessary to, unplug every connection, clean it, get all the corrosion off of there, because that corrosion causes a high resistance, and that resistance can burn fuses and melt wires and such. So it's best that we do this stuff now before we ever try to put power to the bike. So upon investigation, there's a few things on the bike here. The first being the taillights. So you'll notice that the lens is red. I hadn't really thought about it, but this was brought up to me by a friend who stopped by. We're thinking that he actually has the taillights wired as either a run turn or a run brake light. So I can tell there's actually, the wires have been ran to a different area. So I'm getting ready to try to maybe like pin that out or just figure out what they did. And that is one thing. And I want to trust the guy's work because everything else on the bike seems to have been done to a quality level, which is great. One thing of note is the fuse box here. So checking this out. You see that wire? It is actually soldered between two fuse terminals here. So the top one is the tail light, the middle one is the headlight, and he's got them soldered together. Now, if it was just kind of poorly done work, I'd probably undo it, but it seems like, the way he did this, it's kind of a quality repair or modification, just like everything else on the bike. The way he's got his cables ran, it still fits within the actual fuse box cover. I kind of want to trust it. I do want to investigate a little bit further. So the stock taillight fuse was 5 amp, and currently there is a 20 amp in there. And then the stock headlight fuse is supposed to be a 7 amp, and he's got, there is a 7 amp, but the 7 amp is popped. So we have to figure out what that exactly means. Did the headlight have a bad circuit in it, high resistance or something? Was it causing, the headlight to pop consistently, and he was just like, screw it, I'm going to use a 20 amp or whatever? I don't know. Another thing we're looking at here is the wiring that goes into the fuse box. There is a burnt wire on one terminal, so perhaps that wire was burnt, causing a lack of power to go to the actual headlight circuit. So maybe this is repair that he did on the road or something like that. Another thing we have to consider. So I'm getting ready to kind of pin these out. We'll figure out which ones go where and proceed with caution. So I'm going to try to do my best to either de-pin everything, clean everything with a brass brush and some electrical contact cleaner before putting it back together. And I might go ahead, if it seems like the burnt wire is why he has the soldered piece to bridge a connection and give power to the headlight, I might just go ahead and fix all of that. So we're going to dive in now. I'll get my multimeter out. We'll kind of just start tracing some things, and we'll get this thing sorted. So never an easy thing diving into somebody else's electrical work. But again, I feel like the guy who had this bike, he actually did some quality stuff or things that made sense. So I feel a little bit more at ease. We'll find out. Okay, per my deduction, the wire that comes into the actual fuse block, the one that was melted, is actually just the one that runs to the main power fuse right here. So that means it's just like overall being taxed. So looking at the lights, let's go back and review maybe why this wire's here. So up top, after lifting the seat, he actually has this tag right here which just says running. So this wire actually runs down to this light. So these must be a replacement front turn signal that has a 3-wire setup. It grounds through the body itself, and then it has 2 wires coming out of it, one as a run, one as a turn. So one wire is of course running, and then the other is a turn. Now normally these would just be a turn signal, so you got like 1 wire and a ground running out of them, and that's how they operate. But this one, he just wants extra safety. That's why it has a red lens. So we have 3 running lights, which is really cool. So I see no issue with the actual wiring itself. The running light actually comes from 1 wire, and then this looks like an aftermarket kind of a adapter piece from back in the day, because it just branches into 3 wires, so one of which going to either side, and then the center going to the brake in the center. And then as far as the turn signals are concerned, just normal wiring left, right, and then he has the ground wire running as red, which can definitely confuse you a little bit, but that just runs to the center. So I see no actual issue on that front. But looking up here, of course, our melty wire is the main power into the fuse box. So we're being a little bit taxed there. What I'm going to do is actually eliminate the soldered piece there, and then we'll go ahead and I'm going to clip this off, and we'll just re-terminate all of it. We'll clean the wires up, and then we'll just have a fresh connection on that front. I think that will be the way to go. It's a little extra work, but it'll be worth it. So the wire itself isn't broken, but it's obviously missing a few strands and the insulation has melted off. So it definitely experienced a lot of current at one point. Now we could reuse this connector, but I may not, just because we have so many brand new ones on hand. As far as the actual harness itself, I'm going to take back a little bit of the tape right here, and then that's going to allow me to kind of have a baseline of cutting them all about right there, because this one is one of the shorter wires, so we don't have any extra length to play with here. So we'll have to move the whole connector up a little bit, but the fuse box actually has quite enough wiring to, you know, just make a little bit tighter of a bend, and we'll reach it no problem. Very carefully without cutting the wire itself. All right, now to clean up and re-terminate. These are all new and used connectors that I have. These are all new terminals. These are not kits you buy, these are things I have acquired and organized and collected. So, stuff I use all the time. We're going to be using a bunch of these 1/4-inch spade terminals. So wiring is one of my things. All of this is more wiring components. All heat shrink. This is just marine type, so adhesive lined. We have 110 style connectors. We have different fuses, resistors, all kinds of stuff in here. So if you guys want to see more wiring videos, I have plenty. Ah, yes. Like factory. All right, we have everything terminated, so now it's time to just install it in our terminal block. So for this, it's real easy. All you do is you just line up your colors. So being that it's a fuse block, it's just power in, power out. And it doesn't really matter which side is which. You have 3 different colors. You have our main red, you have brown, and then you have brown with red. So we just match them up, not too hard. So for this, we're gonna start with our repair first. This is the shortest one. There's a little tang on the bottom. You just wanna make sure that you line up with the tang in your connector. And this one was up top here. So from there, you just start plugging in. In the middle we have brown. And then over here, brown with red. So that is a nice, new, fresh connector, new terminals. We're pairing that with a nice clean fuse block. We could take this out and clean it, but these are in really good shape. And a fuse block that's unmodified. So plug this in and we should be good to go on that front. We'll clean the rest of the terminals and we'll look for any other issues. And we'll get this thing going. All right, well, I have something I don't like right now. I want to pull the grip off. We have a bunch of very small gauge wiring. Now, it all looks intact, but the reason they did this was to try to get around those bends in the handlebars. And it's all undersized at this point, which I really don't like, because on these old bikes, what you do is you're passing current through the handlebars instead of like a modern, let's say, system like the X21s I used to sell, or like an M unit or something. So that's a lot of current to pass through that little itty bitty wire, especially when it comes to like running the headlight and stuff like that, which might be why we had some issues with the fuse box. So, oh boy, I'm really tempted to fix that, but I think I'm more tempted to just run it for right now, and if it causes a problem, we'll fix it at that point, because I really don't feel like trying to remake the entire harness through the handlebars right now. Now the goal here is actually just to remove the ignition switch, because if you guys remember from episode 1, I did not get any keys with the bike. I did find one that worked for my seat, but I was unable to find a code and a key for the ignition switch itself. So that means the ignition switch has to come off. And it's extended, so we had to do a little bit of work here. What the fuck is that? It's like a mitten. Dudes. Holy shit. Oh my god. Is that a key? Oh. Here's the ignition switch that came on the bike. It's got a 40 on it. This one has a 40N. It looks brand freaking new. Dudes, oh my god. This is amazing. Oh my god. So much better. So what I'm doing here is removing the clutch lever so I can push the actual clutch switch back out, because it's just one more wire tied to the bike. And I am normally one to always just have the bike in neutral when I start it. So for me, this will just clean it up a little bit and get another wire off the bar and make it one less connection that we have to focus on. Now, if I were to keep this bike and really have it as a long-term project, it would be so fun to, well, fun. It would be a great one to rewire with a really modern system, but keep it looking old. You would just have a couple buttons up here. I've actually made another video on that. I'll put up a card now. But that would look really slick and allow you to move the grips in all the way. And we could probably put like a narrow master cylinder on here. Get rid of, the stock controls and stuff. So yeah, that would be cool. And then this, just push straight out. There it is. That's a little bit bent. I could probably squeeze that back into alignment a little bit. We'll get it cleaned up and that'll make it work even better. Way too much grease. A bunch just stuck to my finger. Now, of course, just like above, we have some small gauge wiring in here. There's really nothing I can do about it unless I change all of it. So we're just gonna run it for now, and we're gonna hope for the best. Now, saying that, I don't see anything that's really alarming other than just the diameter of the wire or the gauge of the wire. So, this guy doesn't seem to have led me astray yet. I'm gonna trust his work, and it may not work forever, but it might work for right now. Well, it's not my absolute favorite thing to put this back together with this small wiring, but we're gonna do what we're gonna do. So, and what we're gonna do is put the right cable in in the correct spot. First up, we have our pull cable. Now I've cleaned the cables up and I have been working on getting oil down into them, and they're feeling pretty good. They will be more than adequate to use. I hate letting any weight dangle on these things. A little bit of silicone spray, brand new push-pull throttle tube. Make sure we have no binding. Okay, let's hook our cables up and see what our throttle feels like. I know these are slow to fall because this return spring is not stock. It's always seemed like it's a little slow. Feels good though. All right, now moving down the line as far as things that we have to do to get this bike running on the electrical side, I'm going to test the coils to make sure that we're probably going to have spark. So what I want to do is check the primary and secondary resistance. So what that is doing is checking the resistance between some of the leads here as far as your harness side, and then the actual resistance from like the coil to the actual outputs. So we're also going to check the resistance of the plug caps themselves. So for this, I'm going to be using the two most important things that you should have for any project: digital multimeter and a service manual. Okay. I get a lot of questions all the time, and I'm generally very happy to help where I can, but most of the time, I want to say probably 80% of the time, it's things that can be solved with this. This is the most basic combo of tools that you should have for your bike. So first I will remove my plug caps. They just unthread, and then I will start checking my resistances where needed. Ooh. This one looks a little bit melty. These are just barely hanging on there. Doesn't mean they wouldn't have worked. Now, this is a 4-cylinder bike, but we have 2 ignition coils. So the left coil to me, which is going to be the right coil to you, is going to power cylinders 1 and 4. And this coil is going to power cylinders 2 and 3. So we have 2 leads down here. Now we have 2 harness leads that are going to be a blue and a yellow. So one to the left and one to the right. And then we have each coil having a black with white stripe, and this is going to be your switch 12-volt power from the ignition or the kill switch on the bike. So we're going to measure the primary resistance, which is going to be between these 2 leads on each coil. And then we're going to measure our secondary resistance, which is going to be from the actual coil leads one to the other for each coil. So let me break my multimeter out here. Okay, I have my multimeter set to ohms on resistance. So first we're going to measure our primary for each coil. Does not matter which lead you do where. So this is basically a 5 ohm coil. We're seeing 4.6. The spec is 4.6 plus or minus 10%. So that one is perfect. 4.4. So 4.4 plus or minus 10%, totally good there. And then on to our secondary resistance. This might be a little bit harder to see. This is where your plug caps will go. And then for this one, we should be seeing 15K ohms. So 14.28K. So we're very close there. Totally fine. If it was like 10,000, it might be a problem. But 14.2, totally cool. .36. So the coils themselves are testing good. Now the last step is to test the actual plug cap to see if we have any adequate resistance here. They should be 5,000 or 5K ohm. So we don't even have to change anything on our meter. And these are a little tricky. Sometimes it feels like you can't get them to make contact. .3K for this one, so that's good. .7K, a little high, but I won't write it off. Ooh, 10.1K, so that's quite high. And then this one, I can't get it to make any contact there. So these will definitely cause weak spark or no spark at all. Now these are a common item that I will replace. You saw I just tested all 4. I had 2 fail and 2 pass. So they're normally a cheap replacement item. I had already ordered 4 for this bike before I ever did this test, because I know that typically this is just an item that I like to replace. So one issue though is it seems like NGK has discontinued some of these plug caps. So definitely don't go throwing these away. You want to hang on to them because who knows, there might be some kind of repair or fix later down the road. So I urge you to just hang on to these things for right now. I do the same thing. But yeah, hopefully we can find another source for plug caps and such. I have a bunch of old NGK plugs for this thing. Like I have thousands of spark plugs upstairs, so it's no problem on that front. But as far as these are concerned, we definitely need a good source. Now these came from 4-in-1. They're not exactly NGK branded. It is what it is, so we have to use what we can find. But anyway, just in case you guys are going and searching for some of these, just know that they are going to be harder to find going forward. But with that being said, I will go ahead and install these things on the plug leads here. So I'll probably trim it back just like a 1/4 inch, get some clean wire in here, spread them out, and then thread those on. Okay, we're making headway on the electrical. So you saw I just got the coils back on this thing, getting ready to put some oil in it, and then we can do a electrical systems check. So we're finally to that point. Everything is plugged back in, and basically every connection on the harness I've gone through, inspected, cleaned if I needed to. So now it's time to see what works and what doesn't. Now the front brake switch, the wiring is cracked there, so I know the front brake's not going to work. Not that I can really push the master cylinder anyway. But, you know, that's one area that we know it's wrong. Otherwise, everything inside the headlight bucket looked good. I've cleaned the main contacts. As you saw, I replaced a bunch of terminals. But I'm going to go ahead and throw some power to this thing. We'll hit the key, and hopefully we'll be able to see if the electric start works, build some oil pressure, that kind of thing. So let's get to it. Also note, I am wearing a beanie inside because it's like 54 degrees in here. It's -7 outside right now. It feels like -22 to the weather app. So yeah, it's pretty brisk in here. All right, let's give this a shot. Neutral light, the overhead light, front running lights, they're dim, but the rear running lights work. Okay. Try rear brake. That works. Okay, headlight off. Those are off, so that's on the headlight power. I can hear the chirper. Somehow that still works. But flasher's probably dead, which is fine. There are worse things. Okay. Yeah, it's got a major drain here somewhere. Okay. Let me check my battery voltage real quick. It is very dim. Oh yeah, we're only at 8 volts on the battery. Okay. The battery's dead. So far so good though. Alright, let's go ahead and check for spark on this thing. Pretty confident here. Let's hook up our power. Have an extra plug. Also, if anybody needs some D8 ES plugs, I literally have over 1,000 of them. They're on my eBay store. We're on the number 4 lead, so this test cylinder is 1 and 4. That's on. You just barely see it, right? Yep. Okay. Fill cylinders 2, 3, which are on the same coil as well. These are a little bit more tricky. All right. See it? Might be bad ground. Okay. All right, so we have spark on all 4 cylinders, and that should be it, but we do not have electric start. So I need to diagnose a potential issue on that side. So come around, I'll kind of tell you exactly what I have found so far. Okay, now hitting the button, nothing seems to happen on the starter solenoid. See, you would assume that maybe the solenoid is bad. So instead of throwing the parts cannon at it, I just got taught this term by Seth here behind the camera. We can test these things. So throw power to it. Sorry, I'm gonna throw power to the other side. It really doesn't matter on this particular item. And then use our cable here. And you can hear the solenoid collapsing. So our solenoid itself works. The issue is that we do not have the proper signal on these two wires from the harness. So we need to figure this out. Now, on this bike, I'm trying to determine exactly what year the harness diagram follows, whether it's a 75 or a 76. This particular bike, I think, is a build date of September of 75. So I think we're right on that threshold. But coming out of the harness, we have a black wire, which is switch 12. And then we have our, I think it used to be yellow with red stripe. That should be our ground path. Now, I did eliminate the clutch safety switch, and that ground circuit goes directly through that. So I need to kind of get in the bucket and figure out exactly where I went wrong on that, and maybe just make a jumper where necessary. So again, you guys saw me remove that clutch switch, so there should be an area in here. I might be able to like reroute one wire to bypass it. So I'm gonna do some digging and I will figure out how to do that here momentarily. That's yours? Okay. All right, so going through the diagram, what makes sense is because I eliminated the clutch switch, we're not seeing a ground path from one side to the other. So I want to show you how the switch works. We're going to wire this thing on continuity test. It's going to beep whenever it makes contact. So this is the original clutch switch. It's got that little button on the end of it, and that gets pushed. So whenever you pull in the clutch, that's what lets this tab go, or lets that release. So whenever you don't have your hand on the clutch, or you're not squeezing it in, this is being compressed. So these two wires are inside here. I'm gonna grab that end. So right now, this would be like you pulling in the clutch, okay? The switch is pretty wonky. Yeah, a little break in that. That would ruin your day right there. All right, so this is like when you don't have your hand on the clutch, there's no continuity between these wires. And as soon as you pull in the clutch and wiggle the wire, that's when the wires have continuity. So that's when it would have a pathway to ground, allowing the bike to start. So the situation for that would be, if you're not in neutral, you can pull the clutch in and then you can start the bike. Now I just normally eliminate the clutch switches on mine. I prefer to just put the bike in neutral. I know I'm me, I'm not asking you guys to do the same thing. I'm not saying this is better. That's just how I do it. So I'm going to just make a jumper real quick in the harness, tying those two together, and then we should be able to see ground path on that end for the solenoid. So let's go ahead and make a jumper and test that out. All right, one jumper. So these are using some 3.9 size bullet connectors and then just some 16 gauge wire. So this will just plug into either end of the harness and we should be able to start this thing.
A few moments later.
Okay, we've been messing with this thing for quite a while. I have attempted to bypass the safety unit for the starter. We just can't get ground where it needs to, so we did a little bit more probing in the headlight bucket on the wiring for the actual starter button. And from what we've seen, the button is not making continuity here. So of course, this is where that tiny wiring comes into play. It could be broken right there, it could just be dirty, but I can't really disassemble this in a way that to me is worth the risk of doing so, if that makes sense. It's so small, I don't want to let it hang or drag on here. because I fear we're just going to break another wire. And as of now, everything else on the bike works. And it's a CB750. I really don't care about electric start at all. On my blue CB750 back there, I never even put a starter solenoid on it because I just like kicking it because it helps me slow down a little bit. And you know, Seth, this is a chopper, right? You know, it's got to be kickstarted. Knuckle or Panhead or whatever, those guys always make videos on not being able to start their bikes and leak oil everywhere. So I want to be part of the club. So we'll just kickstart this thing for now. But yeah, at this point, this thing is done electrically. We have gone through the carbs and it's ready to start. And what's also ready to start is that CB750 right there. So me and Seth here are at the exact same point with these two bikes. But it's like minus a million degrees outside and we need to wait until a warm day to wheel these things back there and go ahead and attempt that first start. So definitely stick with us. I'm going to be making a video on that thing, and then we'll probably make a combined first start video for both of these. So that would be really cool. Anyway, that's going to wrap it up for the electrical video on this thing. Let me know if you guys have any questions. And look for the next video on the channel on who knows what at this point, because yeah, we're working on all kinds of things. So anyway, hope you guys like this one. Hope to see you in the next video. Thanks for watching.